I think it would help to sort of go through a typical acquisition process step by step for EEG to explain the parameters that you can manipulate to obtain the desired information in a reading. So first, we set up recording software to apply certain filters and clarify data. Then the EEG cap is placed on a participant and the electrodes are filled with gel. If there are any issues with impedance, you try to address them at this time by manipulating the gel and electrode contact, and abrading the scalp is necessary. Once everything's acceptable and good to go, we'll begin the task, whether it's sit quietly and observe just natural activity or do a cognitive task, and we'll see how your brain responds to different stimuli. The electrodes are plugged into an amplifier that feeds the data acquisition computer. The stimuli and the ERP tasks are very carefully planned out in advance to elicit these responses. Pilot testing and research on others who have done similar things is necessary. They get very specific. For instance, a P50 task would have auditory stimuli that are very short, maybe 40 milliseconds, spaced by half a second, and pairs with the pairs separated by 8 to 10 second jitters, and then done for so many times. So trying to get at reliably eliciting these responses. So participants might be presented with tasks that they're listening to sounds, doing visual searches, solving math problems, or meditating. And participants will always be instructed to stay as still as they can, try to reduce blinking, which is another type of muscle artifact. And let's see, after the laboratory session is over, data analysis begins, and each recording file is corrected for artifacts using semi-automated processes, visual inspection as well, removing those eye blinks and those muscle movements. Sometimes data are noisy and you need additional filters to clear them up. But sometimes data aren't always salvageable if the recording was not done well and impedance was too high. So you must be very careful not to massage the data and keep applying filters. In that vein, we take averages of responses over many trials to try to get at the true response. Since ERPs can be fickle and not always show up, some may have been compromised with artifacts as well. These are all important things to keep in mind. Let's see. So latency is the timing, and amplitude is the voltage or strength of response. These both vary, as well as averages. So again, the mini trials are desirable. And depending on your experimental design, of course, you'll probably also want a good number of research subjects for a grand average of your data.